Welcome to Spaceverse, your portal to cosmic adventures. The James Webb Space Telescope has made an astonishing find. Bright lights on Proxima Centauri b, an exoplanet roughly 7 trillion miles away that resembles city lights here on Earth. Are we ready to confront what might exist beyond our own stars? Could this be a glimpse into a civilization unlike our own? What secrets might they hold? And what could this mean for the future of humanity? Signals from deep space have captivated scientists worldwide as they work to unravel this incredible discovery. Webb's recent observations suggest these lights may not be random, pointing instead to potential signs from an advanced society on Proxima Centauri b. Each flicker and flash across the vast cosmos nudges us closer to what could be the most groundbreaking revelation in human history: communication with another world. This area of space was once thought to be quiet and desolate, but it may now be teeming with life. Every new detail takes us closer to possibly rewriting our understanding of the past. Stay tuned as we learn more about the discoveries from the James Webb Telescope, each one bringing us closer to answering the timeless question: are we truly alone in the universe? The James Webb Space Telescope has set its sights on Proxima Centauri b, a distant planet, and made a thrilling discovery: lights that resemble city lights on Earth. Could this hint at a civilization on this far-off world? The possibility has experts buzzing with excitement, suggesting they might finally be seeing evidence of intelligent life managing their own communities in ways we haven't imagined. According to astronomer David Kipping from Columbia University, Proxima Centauri b is an incredibly complex planet. Its unique connection to its star, Proxima Centauri, gives it unusual behaviors unlike typical rocky planets, which absorb light and radiate infrared energy. But there's even more to uncover. This remarkable find showcases the telescope's cutting-edge ability to detect infrared light, revealing how much there still is to learn. To understand if Proxima b's heat signals could indicate an atmosphere that supports life, scientists are eager to continue exploring its environment. The telescope's keen sensitivity to infrared light gives it an incredible view of what Proxima Centauri b does after dark. While other telescopes struggle with dim lights from space, Webb can catch even the faintest flickers, making it an ideal tool to verify if these mysterious lights, potentially city lights on Proxima b's shadowed side, are the real deal. The James Webb Space Telescope is sensitive enough to detect artificial lights in space by capturing waves at a distinct, much lower frequency than those from stars. Proxima b orbits very close to its star, meaning solar panels on the side facing the star could capture plenty of energy, while some light would reflect off the border where the day side meets the night. As Proxima b orbits, it experiences day and night cycles similar to Earth's, with warm days and cool nights. The planet's materials cause its temperature to shift significantly between these cycles. If Proxima b lacks an atmosphere, the temperature difference between day and night would be extreme, with the hot day side plunging to freezing temperatures at night due to the absence of atmospheric gases to moderate the temperature. Astronomers find these temperature swings intriguing as they reveal insights into Proxima b's atmospheric composition. Thanks to its excellent infrared imaging, the James Webb Space Telescope can track the planet's heat levels, offering valuable clues about the atmosphere. But here's something even more fascinating. Webb's orbit around Earth is perfectly timed with Proxima b's, allowing it to observe the planet's day-night cycles every 11.2 Earth days. Next up, researchers aim to study Proxima b's composition to determine its habitability. If oxygen, water vapor, or methane, key indicators of life-supporting conditions, are found, it would suggest the planet could support life. These findings would then lead to further observations of light passing through Proxima b's atmosphere to deepen our understanding. While the James Webb Space Telescope can only examine a few nearby planets with the potential for life, the upcoming extremely large telescope promises a broader and deeper look at distant worlds. Set to begin operations in 2028, the ELT will allow scientists to study a wide range of exoplanet atmospheres and assess how likely they are to support life. The scientific community is eagerly awaiting the discoveries the ELT and other next-generation telescopes will bring. Despite some limitations, the James Webb Telescope remains an essential tool for exploring planets beyond our solar system, continuously providing data that could reshape our understanding of the universe. Each new discovery adds to our journey toward a potential breakthrough. Exciting advancements in telescope technology are also in the works. New space cameras are being designed to reduce star brightness, making it easier to spot planets orbiting them. Like shading your eyes to see more clearly in bright sunlight, these advanced cameras will filter out the star's intense light, enhancing the view of distant planets. By dimming the star's glare, scientists can get a clearer look at these planets' atmospheres, helping to determine their potential for supporting life. This isn't an easy task. Scientists must carefully distinguish between gases produced by natural sources, like volcanic eruptions, and those created by living organisms. Their mission is to decode these distant worlds with precision, ensuring they aren't misled by natural processes. The James Webb Space Telescope opens up new possibilities for discovery, and with every step forward, we're building a more complete picture of the universe and our place in it. For ages, humanity has wondered if we're alone in the cosmos, a question that still fuels the curiosity of many experts. The JWST is currently observing various planets and moons in search of signs that life might exist beyond Earth. There's growing interest and excitement about the possibility of finding life on other planets, and each discovery brings us closer to understanding if we share the universe with other forms of life. In 1984, American scientists Jill Tarter and Thomas Pearson launched the Search for Extraterrestrial Intelligence, a nonprofit organization dedicated to finding radio signals from space, possibly sent by intelligent beings. Radio waves are ideal because they remain strong even over vast distances. At the heart of their search is California's Allen Telescope Array, a network of 42 radio telescopes. For over 30 years, SETI has been listening, yet clear evidence of alien life remains elusive. Still, Tarter is optimistic. With today's advanced technology, she believes a breakthrough could be just around the corner. She envisions a world united in the quest to answer the age-old question: are we alone? NASA recently hinted that the James Webb Space Telescope might have spotted something resembling city lights on a nearby planet, sparking a wave of excitement. Positioned 1 million miles from Earth, the JWST is essential for deep space exploration, sending back data on some of the universe's earliest formations. This data helps us understand the origins and development of galaxies, stars, and planets. With advanced technology, including precise cameras and specialized filters, the JWST analyzes the light from stars and planets. By focusing on specific wavelengths, it allows scientists to determine the physical and chemical composition of distant worlds. But that's not all. Its capability extends beyond mere observation of these planets. It studies their atmospheres, seeking even the faintest signs of life. The JWST is ushering in a new era of cosmic discovery, revealing surprising details about massive galaxies and uncovering much more than previously thought. This is prompting scientists to revisit their theories about how the universe began and evolved. Each new discovery brings us closer to understanding the far reaches of space and the potential for life beyond Earth. The telescope is helping scientists gather groundbreaking insights about distant planets, pushing the boundaries of space exploration and raising exciting questions about the universe and our place in it. 2 decades ago, our knowledge of worlds beyond our solar system was limited, but since then, astronomers have discovered over 4,000 exoplanets orbiting distant stars. This remarkable progress reflects our growing curiosity and technological advancements. NASA believes we're just scratching the surface, with trillions of exoplanets potentially still waiting to be found. As scientists continue their search, they're especially focused on finding worlds that could harbor alien life, and sometimes they encounter hints that guide them in the right direction. One such clue came from the Galileo spacecraft, which, while studying Jupiter, accidentally detected a biosignature known as the vegetation red edge, a telltale sign that could indicate the presence of plants. This breakthrough marked a key milestone in the search for life, as the VR measures how light reflects off vegetation to detect signs of life. Now, with the James Webb Space Telescope fully operational, the search for life beyond Earth has reached a new level. The JWST can zero in on exoplanets within habitable zones around their stars, analyzing potential biosignatures like the VR. If these indicators of life are confirmed, it could revolutionize our approach to finding intelligent life and open up thrilling possibilities for future space exploration. Here's how it works. As sunlight travels through a planet's atmosphere, it splits into different wavelengths that are absorbed by specific atoms and molecules, creating a unique spectral fingerprint. Using spectroscopy, scientists can analyze this pattern to learn about the atmosphere's composition. With starlight illuminating these planets, the JWST has a rare opportunity to detect this light as it passes through, helping us decode the makeup of distant atmospheres and inch closer to answering the question, are we alone in the universe? These findings could be transformative. The James Webb Space Telescope might just be the essential tool needed to analyze the atmospheres of distant planets. Planets with Earth-like qualities tend to have atmospheres containing oxygen, nitrogen, and carbon dioxide, gases that are compatible with life as we know it. But if JWST detects unusual or unexpected compounds, it might indicate the presence of entirely new life forms or even advanced civilizations. Imagine if the telescope picked up signs of industrial chemicals like chlorofluorocarbons, which are human-made and used in refrigerators and factories. Such a discovery would be revolutionary, hinting at the potential existence of intelligent beings elsewhere. As we complete this chapter of space exploration, we're standing on the threshold of new possibilities for uncovering more about alien atmospheres and the broader potential for life in the universe. Discovering such signals could open countless avenues for scientists, allowing them to investigate not only the potential for life beyond our solar system, but also the diverse types of atmospheres that could sustain it. When we think of life beyond Earth, many of our assumptions revolve around conditions similar to Earth's, but the truth could be far more intricate. Consider extremophiles, microorganisms that flourish in environments otherwise inhospitable to life. These resilient life forms thrive in conditions like extreme heat, as high as 250 degrees Fahrenheit, and highly acidic environments with pH levels below 3. Their adaptability highlights just how varied life can be, even in conditions we think were unlivable. As we continue searching for habitable planets, these surprising examples of life on Earth push us to broaden our perspective of what's possible. This is only the beginning. Space is vast and full of unknown possibilities, so the search for life beyond Earth needs to be wide-ranging and open-minded. The first focus might be on planets orbiting stars similar to our Sun, but expanding our studies to planets around red dwarf stars, by far the most common type of star in the universe, could yield exciting findings. Although red dwarfs are cooler and dimmer, they are also incredibly long-lived, giving ample time for life to develop and evolve in unique ways. By looking at planets orbiting these stars, we may begin to uncover the adaptability of life in ways we never imagined. The TRAPPIST-1 system is a fascinating find, a red dwarf star with 7 rocky planets, many of which resemble Earth. Of these, 3 are thought to be in the habitable zone, meaning they might have liquid water on their surfaces. Even though TRAPPIST-1 is smaller and cooler than our Sun, the gentle light it provides could still support life on these nearby planets. By studying how this star's light interacts with its planets, scientists are gaining insights into the potential for life in this unique system. Recently, the James Webb Space Telescope pinpointed TRAPPIST-1 as just 41 light-years away in the constellation Leo, making it an excellent target for future research. But the JWST's findings about the TRAPPIST-1 system are just one part of its groundbreaking work. Lead researcher Ward Howard, a NASA Shawn Fellow from the University of Colorado Boulder, expressed his excitement over these discoveries, noting that JWST has greatly expanded our understanding of planetary atmospheres similar to Earth's. Howard emphasized the need to understand stars like TRAPPIST-1 to get a complete picture of the worlds orbiting them. Another nearby star that stands out is Proxima Centauri, located just 4.25 light-years from our Sun. Because Proxima Centauri is quite dim, it's tough to see from Earth without a telescope, and any planets with life would have to orbit it much closer than Earth orbits the Sun to stay warm. In August 2016, astronomers confirmed the existence of Proxima Centauri b, a rocky planet in Proxima's habitable zone. This Earth-sized planet has about 1.3 times Earth's mass and orbits its star very closely, much closer than Mercury does to the Sun. Its position in the Goldilocks zone, where temperatures might support liquid water, hints at a potential for life. Discovering Proxima Centauri b was no easy feat. Astronomers had to rely on highly sensitive instruments to detect how the planet's gravity created subtle wobbles in the star's motion. Since Proxima Centauri is so dim, finding its planet required extraordinary precision. But now, this discovery has opened up exciting possibilities for studying Proxima Centauri b, a nearby world that could hold the conditions necessary for life, right in its own habitable zone. However, there are significant risks to consider. Proxima Centauri, the red dwarf star that Proxima Centauri b orbits, is known for emitting powerful flares. These intense bursts of radiation could expose the planet to levels of radiation much higher than what we experience on Earth, potentially damaging its atmosphere and diminishing its capacity to support life. While the discovery of Proxima Centauri b is an exciting leap forward in our quest to understand the universe, it also raises critical questions about the planet's habitability. Scientists eagerly anticipate the arrival of new telescopes like the James Webb Space Telescope and TESS, which will enhance our ability to study the atmospheres and environments of exoplanets like Proxima Centauri b. But this discovery prompts deeper inquiries. What specific conditions have shaped Proxima b? Is it truly capable of sustaining life? Future missions are set to explore these intriguing questions at just the right moment. Proxima b orbits its star at a mere 4.6 million miles away, which provides enough light to melt any frost and potentially kickstart the conditions necessary for life. However, this close proximity also places the planet at risk, making survival for any potential organisms quite challenging. The strong solar winds emitted by Proxima Centauri pose a serious threat as they could strip away the planet's atmosphere. Despite these hurdles, Proxima b receives a suitable amount of light to maintain surface temperatures that could allow for liquid water, a crucial ingredient for life as we know it. Its close orbit results in tidal locking, meaning one side of the planet is perpetually illuminated while the other remains in darkness, much like how the moon is always facing Earth. While Proxima Centauri may be a small star, it still emits enough heat and light to create conditions that could support life, similar to Earth. But we must remain cautious. What if the lights seen on Proxima Centauri b aren't indicative of an extraterrestrial civilization? Perhaps they are merely natural phenomena or even optical illusions. The mysteries surrounding this planet continue to intrigue and challenge our understanding of what life might look like beyond our own world. And that's it. Thanks for tuning in to Spaceverse. We've explored the James Webb Space Telescope's exciting discoveries, from the potential for life on Proxima Centauri b to the mysteries of the TRAPPIST-1 system. Stay with us as we continue to uncover the wonders of the universe. Don't forget to like and subscribe and keep your eyes on the stars.